Hi everyone, today I'm going to show you how to change Epsom salt into pure copper sulfate crystals. For this experiment you will need a container, a plastic container or a glass container, a clay pot. Mine had a hole, so I filled it up with resin with some epoxy. You will need a power supply. This can be batteries, but I like to use a voltage, adjustable voltage power supply so that I can use the current that I want. You will need 2 copper electrodes. Make sure that they're very clean. I scrub them by using some steel wool. You will of course need Epsom salt, water, and usually for this kind of experiment we like to work with distilled water, but here in our case it is not necessary because in the first part of the process the copper sulfate that we are going to produce will be impure, so there is no point in using distilled water. So we are going to produce impure copper sulfate and then we will purify it. I will show you how. You will also need some alligator clips and optionally a scale. So, well, let's start by making a mixture. So here I have 600 milliliters of water and I'm going to dissolve 100 grams of Epsom salt. It doesn't have to be very precise. Actually, I don't know, maybe we could get better results by using a less concentrated solution or more concentrated. I haven't tried yet. Okay, so here I'm using 100 grams of Epsom salt in 600 milliliters of water because I got really good success by doing so. So let me measure this. And again, this doesn't have to be very precise. So it's okay if you have 1 milligram more or less, okay? So here I have 50 grams and let me add again 50 grams. Alright, that's good enough. Let's stir the mixture. Make sure that all the Epsom salt is dissolved. Okay. And I'm going first to fill up my clay pot. Put it in the container and then pour the rest of the solution in the container. Now put one electrode in the clay pot and the other one in the container. The one that is in the pot, I'm going to connect it to the cathode, and the other one, the anode, will be in the plastic container. turn on the power supply. Let me select DC current, and typically I use about no more than 1 amp. Here my power supply doesn't go above 10 volts, so currently I have 950 milliamps, but as the electrolysis is progressing, my current is going to decrease. So what is going on here? What we have is that the clay pot allows ions to flow in and out, but it doesn't allow neutral molecules to go through. And what is going to happen is that at the cathode we will generate some magnesium hydroxide, and at the anode we are going to produce some copper sulfate. And so the point is that the sulfate ions that are in the clay pot, they are going to go out, and the OH ion are going to go into the clay pot. Now this will not be a perfect separation between the copper sulfate and the magnesium hydroxide. There will be a little bit of pollution from one of the solution into the other, but that it's okay. It will be easy for us to purify the copper sulfate. Okay. So, well, at this point, all we have to do is to wait several hours. I'm going to let it run like this overnight, and then we will see tomorrow what we have. Okay. Now, let me just show. You see all those bubbles. I'm trying to focus. There's not much light, I'm sorry for that. I have a flashlight here, let me grab it. Maybe you see those bubbles. Okay, so the cathode is already turning gray or white. That's the magnesium hydroxide that is forming. Okay, and at the anode there are no bubbles. That's because what is happening at the anode is that the copper is being oxidized, so it comes off the anode and it will replace the magnesium in the Epsom salt. The point is that copper sulfate has the formula CuSO4 and Epsom salt has the formula MgSO4. So all we have to do is to replace the magnesium atom by a copper atom. Alright, now you can see that the solution in the plastic container is already turning a little bit bluish, so that's the sign that we already started to form some copper sulfate. Okay, so well, let us let this go for overnight, and then we'll see what we get. It has been 11 hours and the current dropped down to 520 milliamps, and well, you can see how the solution is turning into this blue color. So definitely we are making copper sulfate. Okay, and you see that here in the clay pot we have a relatively dirty solution of magnesium hydroxide. It's mixed with some copper sulfate because we can see a very light bluish component, But the copper sulfate solution seems to be very clean. There is, of course, some here. This is the anode that is decomposing. That's normal because we are taking copper from it. But it's okay because this reduced copper doesn't dissolve in the solution, so we only have to filter it. Okay. I'm going to let this run for a few more hours and see how it evolves, and then we will filter the copper sulfate solution, and then I'll show you how we can purify it, because there is probably some magnesium hydroxide that leaked out of the clay pot into it, so we want to get rid of it. We want really pure copper sulfate crystals. Alright, so this thing has been going on for 36 hours, so I'm going to stop it here. Well, first you can see that my electrode, the anode, has been corroded, so that's just the copper that was taken from it and that replaced the magnesium in the Epsom salt. And well, let me stop this. Okay. Well, actually, I'm going to take this and put it here. So here we have our polluted solution of copper sulfate, and well, the first obvious things to do if we want to purify it is to filter out all the pieces that did not dissolve in the solution. So that's mainly pieces of copper, of metal copper, not ions. So let me start by filtering this out. And so this solution is impure because it has the copper sulfate that we want, but some of the magnesium hydroxide that was in the clay pot probably leaked out of the pot and got mixed up with the copper sulfate. And also it may remain some Epsom salt that wasn't electrolyzed. Okay. And maybe there are also some secondary reactions that gave other products. I don't know. So, and now we want to get some pure copper crystals, copper sulfate crystals out of this. So how can we do this? Well, what I'm going to do is first to increase the concentration of this solution simply by boiling off the water. Okay, so that will increase the concentration of copper sulfate, but of course that will also increase the concentration of impurities. So, by increasing the concentration of copper sulfate, I will produce a supersaturated solution, and then I will let it rest for a while, and what will happen is that the copper sulfate will crystallize. And the cool thing about crystallization is that nature automatically separates the components. So the copper sulfate crystals that we will get will be pure. So let me boil off the water first. Okay, so let me turn this thing on. And currently I have about 400 mils of solution, and I'm going to boil off the water until it gets dark enough. I don't know, maybe until I end up with only 200 mils, and then we will let it crystallize. Okay, now I don't know exactly what are all the components that are in there, so there might be some things that are a little bit toxic. So in principle you should do this outside or in a fume hood. It's too cold today for me to go outside, and I don't have a fume hood, so I'm just going to pretend that I have one. One day I will have to build one. So okay, well, let's wait for this to reach the boiling temperature, and then we'll see. Alright, there's about 200 mils left, so I'm gonna stop here, let it cool off, and then we will crystallize it. The solution is now cold, and you can see that there are some impurities in the bottom, so I'm going to filter it again. Oops, maybe I put a little bit too much. Oh, it's okay. Alright, I made a big mess. It's okay. I'm gonna clean this up. So now we're gonna see what we can do in order to crystallize it, to help it to crystallize. So now all we have to do is to wait for the solution to crystallize, and well, this will take several days or maybe weeks, but we can accelerate the process if you have a seed. So what is a seed? A seed is just a piece of copper sulfate crystal. So I kept one from my last batch, and all you have to do is to attach it to a thread and dip it into the solution. Okay, and this will initiate the crystallization. It will still probably take several days, but it will be faster. Okay, so well, let's wait for a while, and then we'll see what we get. It has been 16 hours, and the crystal already started to form. Let me try to zoom. And the seed got bigger. So this is pure copper sulfate. All right. It has been 40 hours. The crystal got bigger, and I could wait for a longer time to see if it grows even bigger, but for the demonstration I'm gonna stop here. So look at this beautiful copper sulfate. It's really pure. Okay, here I'm using a glove because I don't want to put some grease onto the crystals. I want to keep them pure. Okay, so now, oops, I shouldn't have touched it with my other hand. That's okay. So of course here there is not much copper sulfate, but once again I could have let it grow for a longer time, and you can just scale this up if you want more copper sulfate. Okay, I just wanted to show the principle how it works. Okay, so thanks for watching. Please register to my channel, give it a like, and I would appreciate if you can also share my video on your social network.